This is the first video for Chapter 14, Graphs 1. The chapter covers linear graphs, quadratic graphs, and then kinematic graphs. Also the first video with my lockdown haircut. So this is 14.1, which is purely looking at linear graphs and their graphs when you've got an equation that has got the highest power of x being x. We'll look at some examples to make that a little bit clearer. This print comes straight from the book, the higher book, page 274. And it's got on it two straight lines. Y equals 2x plus 3 and y equals 2x minus 3. Both of these are straight lines. They're linear equations to give you straight lines because x is not raised to any power. It's being multiplied by 2, but it's not being raised to a power. And they're in the general form of a linear equation, which is down here, y equals mx plus c. So the m affects the line, and the c affects the line. M is what we call the gradient, and that's how steep it is. So whatever number that is how much it goes up when it goes across 1. So across 1 up 2 because it's 2x. Across 1 up 2 because it's 2x. C, the intercept, is where it goes through the y-axis. So 2x plus 3 goes through at 0, 3. Because x is 0, y is 3. When we've got this one, it goes through at minus 3. So we've got 0, minus 3. X is equal to 0, and y is equal to minus 3. These are called the intercepts. When I've got two lines that have got the same gradient, 2x and 2x, it doesn't matter anything about the intercepts. If they've got the same gradient, these lines are going to be parallel to each other. You should also remember from previous chapters that we do have lines that go straight up and straight across. So straight across, those are called y equals something. So this is y equals 3, because every point on there, y is equal to 3. This one here is going to be x equals minus 4, because every point on there, x is equal to minus 4. This slide is a summary of what I've just been saying, just to remind you that key formula you need to remember for a linear graph, a linear equation, y equals mx plus c. M is a gradient, tells you how steep it is. The bigger that number, the steeper the line. The gradient is 2. Remember that means when it goes across 1, it goes up 2. If the number was 3, when it went across 1, it would go up 3, so that's steeper. We will come across some negative gradients later. Positive gradients we've seen going in that direction. Negative gradients go in that direction. Essentially, as we go across that way, it goes down. That's for a negative gradient. And then we also spoke about C, the number on the end, which is the intercept on the y-axis. Here we can see 3 different examples of linear graphs, which we'll look at and compare to their formulas, and also an equation to work out the gradient when you can see the line in front of you. So I'm going to work out the equation of this purple or dark blue line. And the first thing to do is to pick out 2 points that you can read clearly because you've got lines that they go through. So it goes from 0 across to 2 and from 0 up to 6. You don't have to start at 0. You could start at any point where you could read it clearly. So you could start from there if you could read it clearly, or there where you can read it clearly. But I've just picked this one. It's right in the middle. So it's gone across 2 and up 6. So the change in y is 6, and the change in x is 2. So 6 divided by 2, the gradient is 3. And there you can see the equation is y equals 3. There's no value of c on the end here, and that's why its intercept is at 0. The intercept is 0, 0. If we look at the green line, that's 1x compared to 3x, so it's not as steep. And if we look at the C value, it's -2, so here it is going through at -2, and the line you can see is less steep. If we look at the red line, this is one of the negative gradients that we spoke about, and that is going down that way. So as it goes across, it's going down because it's got a negative gradient, -3. So when it goes across 1, it goes down 3. If I put that in the gradient, it's changing y is -3, changing x was 1. That's where the negative comes from, -3 divided by 1. This one I've given you an example of how to actually work out the points and draw the graph. So we've got an equation that we've seen before, y equals 2x plus 3. You'll be asked to do it for certain values of x. So 2x, 2 lots of -3 is -6, and I need to add on 3. -6, add 3, I get -3. So the x is -3, I've also got y -3. So here's x is -3, there's a point, y equals -3. So each of these is actually going to be a coordinate. The coordinate for that one there is -3, -3. The coordinate for this point, when x equals 2, is 2, 7. So x is 2, y is 7. 2, 7. Plot the point. Again, to work it out, 2 lots of x is 4, then I need to add on 3. 4 add 3 is 7. This is actually the first question in the book, so look back at this and then copy it out and give it a go yourself for question 1 and then move on. So now I will actually move on to those questions and start working on that for you. And today I'm going to try and do that by actually using Caboodle. So here we are in Caboodle, and I've just done that line for you. Y equals 2x plus 3. It's asking you to do it between 0 and 5, so obviously you'll need to change those points. I just wanted to give you an example with some negative numbers. So each of these will just be drawing out a table of results and then drawing the line. Just be careful when the numbers get a bit awkward and make sure you don't make daft mistakes. Number 2, on the same set of axes. So that means that you draw all of these graphs on one set of axes and you can see the sort of comparison between them. These are just straight lines because they're y equals or x equals. So you'll get a series of straight lines going across or up and down. Then we've got to move on to this one. If you look at this one, it's not in the correct form. So it's going to be important that you swap that around to make that y equals 8 minus x and then plot that point. This is a negative gradient because it's minus x, so that one will be one that's going down. Again, this will be -1 because the x will come across here and give you y equals -2 minus x. If you look at all of these, they'll all give you negative gradients because the x will actually be moved across. And I find it the easiest way to plot these graphs rather than trying to do a different sort of calculation. Number 7. The gradient is 6 and it passes through the point 0, 2. So I know the first bit of the equation is y equals 6x. Now, the x value it's given me here is 0 and the y value is 2. So I need to do 6 times the x value, 6 times 0 is 0, and then work out what 2 is. So that's going to be y equals 0 plus c. In the general form, c must be 2. And in fact, you should hopefully recognise that 0, 2 is the intercept, which gives you C. So this one here for B is just going to be y equals minus 2x, because that's the gradient, and then plus 5, because 0, 5 is the intercept. Number 8 goes back to that idea of parallel. So a parallel line to that is going to have 2x as well. So you can come up with anything. Y equals 2x or on its own, just y equals 2x, or y equals 2x plus 72, or y equals 2x minus 394. As long as it's got 2x in there, it will be parallel. We'll be going back to the questions in a minute, but just for the last thing that you need to know, perpendicular bisectors. So bisector splits a line in half, goes through the middle of it. Perpendicular makes a right angle. So here we've got a perpendicular bisector. It's going through the middle of that line and creating a right angle. To work out a gradient of a perpendicular line, it's going to be the negative reciprocal. So reciprocal means 1 over, negative means minus. So if you've got a gradient which is y equals 2x, its perpendicular line will have a gradient of minus, opposite sign to that one there, 1 divided by 2, 1 over 2. The perpendicular to this one, negative to this, so that will turn that into a positive. 1 over a half, I hope you realise, is 2. So they'll go backwards and forwards between each other. Now look at number 11 and some use of that perpendicular gradient. It's got perpendicular to 2x plus 4 and passing through that point 3, 7. So we worked out already that the negative reciprocal is minus a half x. So the perpendicular line will have a gradient of a minus a half x. So I know the first bit of the equation is minus a half x. There's my x value, 3. So put 3 into that, I get minus 1.5. So what is the value of c that's going to make this work? When I do that times minus a half, I get minus 1.5. So I need to add on 8.5 to that to get me to the 7. So the full equation is y equals minus a half x plus 8.5 or 8.5, whichever you prefer. Perpendicular to 3y equals 8 minus 2x. First thing I need to spot is divide through by 3. So that's going to give me minus 2x over 3. Negative reciprocal of minus 2x over 3 becomes positive because you've got a negative of a negative, so it's positive. And if I do 1 over 2 divided by 3, I actually just flip it and get 3 over 2. It needs to cross the x-axis at the same point. Putting that together, I've got an intercept of 0, 8 over 3. X is 0, y is 8 over 3. If it's going to go through at the same point, the intercept for the perpendicular line is also going to be 0, 8 divided by 3. So I know that the c value in this one is going to be the same as that. So the perpendicular gradient was 3 over 2x. And then I'm just going to have the same c value, 8 over 3. Okay, hopefully that's enough to help you through this section. Let me know what you thought of me actually just writing on all of these, and I'll be coming back with the video for 14.2 at some point later today. Thank you very much. Bye bye.